In this video, I want to give you an overview over the solution of a problem type similar to one problem that is on the homework this week in week 5. And I want to kind of direct your attention to a couple of very useful actions that Gradarius has that can save you a lot of work and also a lot of errors, or making errors along the way. So here's the problem. A bullet is fired from 6 feet above ground, and its height, so this is the vertical height of the bullet, right, is given by y of t equal to this function. You see if t0, you get 6 here, so that's the starting value. It's fired from 6 feet above ground. And the height is given by this function after feet after t seconds. What is the velocity of the bullet when it hits the ground? So this is the height function. Now we want to have the velocity of the bullet in the vertical direction, so to say, when it hits the ground. So what do we need to solve this problem? Well, we need to find out the velocity, right? So the velocity is given by the derivative of this. Right? So we need to compute the derivative. So let's do that first. Okay. For that, we can always just select the term here. Right? So we select this and start take a derivative. So it asks us, well, what should be the derivative variable? In this case, it's clear, it's t. So I save my work, and then I'll just compute it by applying the power rules successively, the usual stuff. So that should not be a big problem anymore at this point. So minus 2t plus 5. Okay, that's the derivative. Okay, so now we have the derivative, but what are we actually asked to do? Well, we're asked to find the derivative or the velocity when the bullet hits the ground. Well, we have computed the function for the velocity. Now we need to evaluate it actually at the point when the bullet hits the ground. But what does it mean when the bullet hits the ground? Well, it means that this function here is equal to 0, because that's the height function, right? So when height y of t is 0, then that means the bullet hits the ground. So what do we have to do? Well, we have to compute the zeros of this function. And again, there's a very nice action available. So if you just select this and then type 0, so you can select this action 0 and will automatically solve this equation for you. So compute the zeros of this function. That's very nice. So we have actually now two values, t at -1 and t equals 6. But t minus 1 is negative time, which we can exclude because our time starts at 0 here, right, when the bullet is fired at 6 feet of ground. So t equals 6 is our value. So that's the one that we use. So remember, the nice thing here, use the zeros action if you want to find zeros of a function, an expression. That's comes in very handy, especially also next week when we talk about critical points and so on. So what was the other thing we needed to do now? Now we know the time when the bullet hits the ground. It's 6 seconds. Now we need to actually evaluate the derivative at this point. Again, Gradarius has a nice action here. So if I just select this expression, right, and type evaluate at, and select this action here, it will ask me, okay, I want to evaluate it at t equals 6. Okay, and there is the value. So of course, in this case, the derivative is simple, or this expression here is simple enough that I could have done that easily myself. Right, but imagine there would be a much more complicated derivative here where you need to evaluate something. You can just do it by a couple of clicks, and very nice, very helpful. Okay, so now we have our value. So now the only thing I need to do is to copy it and then select, okay, what is it? It's velocity is feet per second. Right? And then submit. Okay, everything looks good. Right. So again, this type of problem should not be too hard, and I wanted to demonstrate this to you on the one hand because I wanted to show you, give you a similar problem to follow, and the other thing, point I wanted to encourage you to use these actions because really they make your life, I think, a lot easier. Okay.